Hey guys, we're recording. All right, you go turn around, please. Thanks. All right, so let's chat about page 7 here. All right, so number 1, yeah, girls, quiet, please. Thanks. We're asked to write an equation of the graph in vertex form. So you're given a graph, you're asked to write vertex form. Now, I still need to kind of talk to the other Algebra 2 teachers what we'll give you as formulas. So I'm not 100% sure what we'll give you, but you should know this, at least know how to interpret it. So remember H and K. H and K is your vertex, right? We know this already. So this is all review. And that little cheat sheet I just gave you guys has it on there, I think in the middle. So H comma K is the vertex. Actually, sorry, it's the far left on that cheat sheet I gave you guys. So anyway, let's identify the vertex. So the vertex is the highest lowest point, right? That's all there is. So the vertex is right here, and for the other one, it's right here. What's going to be the vertex for the graph in A? 2, 1. How about for the second graph?
-3.
Yep, 3, -1. Perfect. Now the A value is a little interesting. It's not terribly obvious what the A value will be. It's not slope. I'm going to warn you, it's not slope. But you do see an extra point here, right? At 3, 0. And we do see an extra point here at 1, 3. So here's how I'm going to write these equations. For part A, I'm going to say y equals a x minus 2 squared plus 1. So I'm 2/3 of the way there, right? Because I already know what H and K are. 2 and 1. So throw it in. 2 and 1 for H and K. Does that make sense? Why do 2 and 1 there? Yeah, because H and K is 2, 1. Just throw it in. It's the formula, right? However, I don't know what A is off the bat. I know it's going to be negative. How do I know it's negative? It's going down, exactly. But let's plug in 3 and 0 for x and y. You plug in 3 and 0 for x, y. This is a good practice because chapter 5, we're going to be doing things with cubes, like raised to the 3rd power, raised to the 4th power. You're going to be doing some really intense graphs in November. And then when I come back in the spring, even more intense graphs. So you're going to want to get in a good habit of finding other points on the graph, plugging them in for x and y, and solving for constants like a or other constants. So I'm going to plug in 0 for y and 3 for x and solve for a. If you solve for a, what do you think you get?
-1.
Thank you, Hugo. Perfect. Yeah, totally -1 because PEMDAS, right? 3 minus 2 is 1, 1 squared 1. That's a positive 1. Move that positive 1 to that side. Divide by 1, you get -1. So the answer is going to be this. The answer is going to be y equals negative x minus 2 squared plus 1. Go ahead, question.
You've gotten 0.3, 3, 0. Oh, you thought 3, 0.
Yes, 3, 0. Now, I know some of you guys are thinking, well, Mr. You can't kind of see the constant slope because technically I did go down 1 right 1. I'm going to warn you, that won't always work, especially when you get to really wacky graphs in the next chapter, like when you get like these with cubes and 4th power and whatnot. You're not going to be able to always rely on that, but you could, if you wanted to, like as a shortcut. Well, if you're going 1 away from the vertex, technically that is the A value. It is kind of like a slope, but it doesn't always work. Just want to warn you. So I encourage you guys to plug in points because that's going to be a more universal technique. That'll be applicable to every function you do in this class. So I strongly recommend find an extra point, plug it in for x and y, solve for a. I'm going to do the same thing for part B. Okay, part B, my vertex, we already know. We know it, right? So I'm going to say y equals a, x minus 3 squared, and minus 1, right? Because it's k is -1. Okie dokie. Plug in another point that you're given, which is like 1, 3. So 3 for y and 1 for x. Okay, solve for a. Tell me what you get. What do you get when you solve for a? Yeah, A is 3.
No, I got that. What's it called? You put Y on the side.
Oh, right. Yes, exactly.
I guess.
Oh, you didn't follow order of operations.
I got 1.
So you have this, AJ. You have 4A minus 1, right? I know what you did. When you worked out this part, the 1 minus 3 squared, you saw the minus 1. You combine those two. So you do 4 minus 1 on the right side. But you can't. You know why you can't? Because it depends on us. A is being multiplied to that. Since A is being multiplied that, you can't combine that with negative 1. It's kind of like if you have like 4x plus 1. I can't combine that 4 and the 1 because they're not like terms, right? So what you have right now is you have 3 equals 4a minus 1. How do I solve for a? Yeah, and so what is a going to equal? Exactly, a equals 1. Exactly.
That's not how I did it.
How do you do it?
I got 3 equals 3a.
And you got it wrong.
Wait, 3 equals 3a?
I still got 1, but
How do you get 3 equals 3a? Oh, okay, guys. Wow. All right, let's back up here. Let's go back to middle school. This is not good. Let's talk about this. So 3 equals a. Again, I'm glad you guys are telling me this because this is a major misconception we have to fix ASAP. Okay, so you got this right. So you got 3 equals a times negative 2 squared minus 1. 3 equals a times 4 minus 1. Right? Can I subtract that 4 and 1? Please don't say yes.
No.
Good. You can't. PEMDAS.
But there's no more
No,
parentheses.
it doesn't matter. It's being multiplied. Whatever value a is,
Oh,
it's going to be
sorry.
multiplied by 4. If you write 5, I can divide by 4 minus 1.
We still got 1.
Yeah.
Oh,
Yeah. Please don't make that mistake. That's one of my pet peeves. Sorry, I'm getting very animated about it. But it's something I don't want you guys to make that mistake. That trend off the station 3-4 years ago.
I think that solves a lot of things.
But it's not your fault we had a pandemic. It's just the way it was. So anyway, A equals 1. Please don't make that mistake. Yeah, A equals 1. All right.
I think that just solves a lot of
Good. It was. Now we're gonna move on. We're not ever come back to that ever again. So we're moving on. All right. Okay. We got a little heated there. Sorry. All right. Let's keep moving. Number 2. You're asked to write in intercept form.
Isn't that y equals to a in parentheses x minus q?
Yeah, I mean, whether you use P or Q or different letters, I don't really care, but it has to be factored, right? And you have to have some letter to represent the intercepts. But we use P and Q, and that's also in the little cheat sheet I gave you guys. So yeah, we're just going to use the graphs from up above, which is kind of unfortunate because I need to see those graphs. Okay, so what are the x-intercepts here?
1 and 3.
1 and 3. Okay, and what are the x-intercepts here, guys?
2, 4.
2 and 4. And now I'm going to scroll down again. And remember, A here was -1. A here was 1. Okay, now let me scroll down. Okay. And let me, oh, bless you. Oh, my goodness. Hold on. Sorry, it's being stupid. Oh, goodness. Here we go. Okay, cool. So anyway, the x-intercepts are easily identifiable from the graphs, right? 1 and 3, 2 and 4. Now the a values, you use the same a values. The a stays the same. So let me, because it serves the same purpose in all the different forms. Whatever you get for a from vertex form will be the same for. It's just factored out. That's all it is. So a is the same between vertex form and intercept form. Which one?
C.
That's a P. Wait. A Q. Yes, that's a Q.
I have a question. Since for like an A equals 1, we want to put a physical one.
Yeah, it's up to you. You don't have to. I mean, yeah, it's implied. Yeah, you don't need to, right? So they totally are. So I'm going to say y equals the following. y equals negative x minus 1, x minus 3. And here I'm going to say y equals, guys, quiet please, x minus 2, x minus 4. Yeah, there we go. Okay, does that make sense? We're okay? We're good? Right. All right, let's try the next one. All right, now this next one's not going to be as obvious as the other ones, but you do have the x-intercepts, right? So the x-intercepts are negative 11 and 3. Okay, so let's go to that. Okay, so you have y equals a x plus 11 and x minus 3. Why am I putting plus 11? Right, exactly. And of course, x minus 3. Now, how am I going to solve for a in this problem? What am I going to do?
You just plug in the point.
Plug in the other point you're given, exactly. So plug in the other point you're given.
Is that 11?
It is 11.
Oh.
Yeah, because you're doing minus negative 11, right? And if you work it out, tell me what you get.
8.
Is that negative 192 or?
Negative 192, exactly.
It's 8. So you get y equals to 8 in parentheses.
So you get 8 for a, Hugo?
8 for A.
Perfect. Thank you so much. So final answer is going to be questions. Okay, let me back up a little bit. Take time. Okay. Sorry, I went a little fast with that. I'll back up. Exactly, and the x. They're all being multiplied together.
What is it?
I'll back up a little bit. Okay, let me back up. I'll back up. I'll back up. Okay. 12 times negative 2, which is negative 20. Yeah. So now let me move forward. So sorry for going too fast. So I have negative 192 for y. I have 1 plus 11 for that part, and 1 minus 3 for that part. Should you get 8 for a? Do you get 8? Okay, so what do you get on the right side? You have 8 times 12 times negative 2.
Yeah.
Okay, cool.
Oh, wait, sorry, you multiplied them. Okay, sorry, that's my bad.
Okay, that's just human error. Yeah, that happens. What the errors I don't want to see is I don't want to see PEMDAS errors, but human error, like you confuse the multiplication subtraction, that happens.
Yes, I got 8 equals.
Cool, excellent. And so final answer is going to be 8 times all that junk. So okay, we're okay. All right, let's keep moving. Got one more page, and then you guys can do homework. All right, so now we're just gonna graph, just practicing graphing. This is just review, nothing too new.
You get positive or negative.
All right, guys, when you graph, Bill, can you put your phone away, please? Thanks. When you graph, you really just need 3 points. The next page. You really need just 3 points. Now, fortunately, this is vertex form. Vertex form is actually my favorite graph because I can easily get the x-intercepts. If I can get the vertex, boom, I've got 3 points. I've got 2 x-intercepts, I've got a vertex. That's good enough to do the graph. The x-intercept should be pretty easy to identify because this is intercept form. What are my x-intercepts here? 4, 4, negative 1.
It's okay. Yeah.
It's okay. All right. Axis of symmetry goes right through the middle. Yeah, so if you go right through the middle, I'm trying to be like really steady hands here. Okay, that I just kind of messed up a little bit. That's okay. Yes, x equals 1.5. That's because 4 plus negative 1 over 2 is 3/2 or 1.5. So why did I add these two divided by 2? Because the axis of symmetry is the average of the x-intercepts. Here's my x-intercepts, just average. I the average. It's the line that goes right through the middle of the graph. 1.5.
What does that say under the x equals 15? Or x equals 1?
Because
AX.
1.5. So x equals 1.5 my axis of symmetry. Okay. Now, to find the vertex, I know it's going to be at 1.5 for x.
Then you just plug in.
But yeah, how do I get the y coordinate? And what do you say, Hugo?
Plug in.
Yep, plug in straight up. This was a little nasty with the decimals, but I'm sure you guys can handle it. Maybe 12.5, I think. Yeah, I think so.
Negative. 2.5.
What is it, 2.5?
1.5 minus 4 and 1.5 plus 1. Just arithmetic, right?
Yeah.
So it's way down here somewhere. If I extend this.
Yeah.
Yeah. So that shows how the graph shows. Good questions. Please ask.
What's the two? Who is A? Or what's
So A, you don't really do anything with it. It's just part of the equation, right? And so when I plug in 1.5 for x, obviously I have to use the 2 on the other side to calculate the y coordinates, which I those is 1.5 for x. So it's just part of the equation. It just impacts what y is.
okay.
Now, if you want to go to deeper details, it does represent the stretch of the graph, as well as let's flip over the x-axis or not. But because we're given vertex now, I don't really have to do anything special. I don't have to say anything about it. It's just there. And just I use it when I confuse the y coordinate versus. But yes, we have had to use another instances like vertex forms, but I didn't have to worry about here. Okay, question how I do that graph. You guys are okay? We're good? Yeah, go ahead. Yeah, please, Haley. You okay with this part?
Yes.
Okay, because that makes sense. You don't make sense.
Okay.
And then 1.5 goes right between these two. 1.5 2.5 away from these numbers. Is the average also of this?
And then you just get, and then you just plug it in the y.
Yeah. Yeah, exactly. And that's what it is. And that's just doing arithmetic, right? Just subtracting times us.
Yeah.
Right.
How would you get?
Well, one more example. We're almost done. Yeah, I'm not doing. I don't like doing more than 2 or 3 pages. Too much. Okay. These guys here. In each case, you have to FOIL. Remember, that means first outside, inside, last. First outside, inside, last.
Can you do the last one first? Because I'm not sure if I got it right.
Sure, why not? We'll do number 5 first because Hugo said so. All right. Now, standard form. In case you guys forgot, guys, quiet, please. Especially the boys in the back. Thanks. Okay, that's standard form. Standard form, you're gonna have to see a lot. You will see a lot of standard form in the second half of chapter 4, especially when you're doing the quadratic formula. Standard form is just when you have it all expanded, right? Ax squared plus bx plus c. If you were to, well, here's what I would do first. We'll do number 5 because we have a request.
Don't you expand it first?
I would do this first because x minus 2 is being multiplied by itself. So it means x minus 2 times x minus 2. Now you have a couple of options. You can distribute the 3 into one of the parentheses, or you can FOIL first. It's up to you. I'll FOIL first just because I want to. So if I FOIL first, so I'm going to kind of take care of this part first, right? If I do that, I get this. Y equals 3, parentheses, x squared minus 4x plus 4. Okay, make sure you guys are with me. I don't want to lose anybody. Okay. So x times x squared. X times -2 and -2 times x is -2x, -2x. That's -4x when you combine the middles. And of course, -2 and -2 is +4. So when you FOIL, you generate 4 terms, but the 2 middle ones are going to be like terms. -2x, -2x becomes -4x. Is that okay? We're okay with that? How I got that? And please don't do this. Again, this is middle school mistakes. This is not high school mistakes anymore. You guys are halfway through high school. Don't make these mistakes. But there's also one of my other pet peeves. I've seen some students do this. What this tells me is that they're extremely careless with the math. That's not true. That is not true. You can't square x and negative 2 separately. Why is this bad?
Because it does not equal.
They don't equal each other, right? Because what if, for example, I had 5 minus 2 squared, right? Could I just nonchalantly say, oh, it's 25 minus 4? Totally. No. Because PEMDAS, parentheses, right? So parentheses is, you do 3 squared, which is 9, right? That's what you're supposed to do when you see 5 minus 2 squared. You're supposed to subtract 5 and 2 and then square afterwards. That's not okay. Like, that's bad. So that's why with the algebra, when you have x minus 2 squared, you don't square the x and negative 2 separately because of PEMDAS. Instead, you have to do x minus 2 times itself. Okay, so that's what you have to do. So we want to make sure we're not making those kind of mistakes. Then distribute, of course. We could distribute down below. 3x squared minus 12x plus 12 plus 1. And do I have any like terms that I can combine? Yeah, totally. Yep, and that's it. So that's going to be in standard form. We're going to do example 4 because we skipped. Yeah, this is the last page of notes. Yeah. Yeah, totally. Yeah, you have like 45 minutes after I finish. Okay, last bit, number 4. Can I clear the screen, by the way?
Yeah.
Can I clear? Okay. Oh, good. Oh, totally. Yeah. All right. Now, be careful with this one. If you want to distribute, go ahead. But you can't distribute the 2 twice. Like, I've seen some students do this. Like, they'll say, oh, I have 2x minus 8, and I have 2x plus 2. I'll see students do this. If you do that, then this should have been a 4, not a 2. Or you need the 2 twice. You can't do this. It's not like you're double dipping. Like, you go to buffet, you don't go twice where other people go. Like, right? If that makes any sense. But you can only use it once, right? Only use it once. You double dip, Charlie?
It doesn't. Double dip what?
The buffet line.
Ooh, you get chips and guac with your arms.
All right. Anyway, so like if you have 2 times 4 times 5, right? I don't multiply 2 to 4 and 5 each. I just multiply the one of them and then keep multiplying. So anyway, you're going to have this. You have y equals 2x minus, well, actually, let's FOIL first.
No. I did minus 1.
It's up to you. I mean, if you distribute it to one time, then FOIL afterwards. It's up to you. Meredith, go ahead. Yeah, sure, yeah. It's your call. But just don't distribute it twice. That's what I'm saying. Because then it's like multiplying by 4. And then if you clean up the inside, you get this. Guys, stop playing with where you're playing. Thanks. And you get 2x squared minus 6x minus 8. And there you go. Now, we want to be comfortable with moving from standard form to vertex form to intercept form and all other permutations of that, because we're going to be dealing with a lot of like complex stuff with this second half of this unit, and also in the second semester. So we want to make sure we're fluid with going between all those forms. Okay, so that's why I had this little exercise here. Actually, we're not done yet. I lied. We're not done yet because I have to go over this too. So actually, I'm going to do the homework with you guys. So I'm going to do the homework with you guys.
Well, what's the homework number?
So I'm going to do some of the homework with you. Yeah. Okay.
So what are we doing?
So here's the homework. Okay. So I lied. There's still more I have to cover. So the homework's going to be 4.5. Numbers 1 through 14, all, and 16 through 19, all. I'm going to do about half this with you guys right now. I'm going to do actually all these problems right here. So then you guys are going to want to do increments and then 16 through 19, all. I think that is how I set it up. Yeah. Okay. So, and actually, yeah, all of this schooled in a little bit. Okay. So you guys probably have seen this in the past. So we're talking about radicals, right? We're talking about radicals here. Root 192. Have you guys had simplified these in the past?
Yeah.
Okay, how do you do it? You guys remember?
You find two squares.
Okay, good. Good. So, or just break it down into two factors. Like, is 192 divisible by 2? Sure, right?
Yes.
So you get 96 and 2. Can I break down 96?
I got 6 root.
Yes, but let me wait till everyone gets. You're totally ahead of us, Hugo.
Just go divide by 4, divide by 4, divide by 4.
Okay, how do I break down 96? I could divide by 2 again. Divide by 2 again. You divide by 4. And then, of course, I have 2 and 3. Okay, there are a lot of 2's there, for sure. There are a lot of 2's. So 1, 2, 3, 4, 5, 6. There are a lot of 2's there. And of course, you have this 3 that's kind of lonely, right? So if you think about it, 192 is really 2 to the 6th power times 3. Or that winds up becoming 64 times 3.
So you go root 64.
It'd be 8 root 3, exactly, right? Now, if you could see that 64 is a factor of 192, more power to you. If you could just see that, oh, here's a big number that's squared as a factor of 192. Square that is 8, so 8 root 3. Cool. A lot of people can't see that. So one thing you could do, which I know is a little bit labor intensive, but if you just divide this by 2, and of course it's not divide by 2, divide by 3, divide by something else, so 5, whatever. But this is called prime factorization. Prime numbers are numbers that have exactly 2 factors. 2 is a prime number because that's 1 and 2 is a factor. 3 is a prime number has 1 and 3 is a factor. So you've broken this down to this prime factorization. We actually call this a prime factor tree, which I assume you guys saw in middle school. I don't know.
Yeah, it makes sense though. Now it does.
So prime factor tree. So that's a way to simplify because we're going to have to use the simplification techniques when we do quad form in the second half of chapter 4.
For 3, since they're both the same, you can't multiply them, right? So since they're both different.
Well, what about 3?
Since it's root 24 and then root 10.
So it becomes root 240.
So you can you just actually
Yeah,
so
yeah.
And then it becomes 15 root 240.
Right. So let's do number 3 down here.
15.
Okay, you're gonna write this 15 root 240. So just so you know, you can combine the 5 and the 3 and the 24 and 10. Because the 24 and 10 are underneath radicals, the 5 and 3 are outside the radicals. You can actually do that. It's actually following properties of exponents, which you'll learn in the spring. Or probably in chapter 5. I can't remember when we do that. Okay, root 240.
Kind of absurdly large number.
I could break it down. So some ways I could break it down. I mean,
Divided by 4.
I could do 24 and 10 again. 2 and 5, right? How do you break down 24?
12, 2.
12, 2.
4, 3. 60 root 15.
So let me get a highlighter out here. 2, 2, 2, 2. And then I have a 3 and a 5. Exactly. So 240 becomes 2 times 2 times 2 times 2 times 3 times 5, I believe. Hold on a sec. It should be 60 root 15, I think.
Yeah, I got 60.
Should be 60 root 15. Let me clear this, the right side.
Oh, because
It's 4 times 50.
Right. But before I move forward with number 3, question if I did the breakdown of 240. Right, cool. Breakdown of 240. Again, you could have broken that 2 120 plus like that. But you still should get the same end result. So you should look 4 times. And 3 and 5. So 240, root 240 is the same thing as saying this. 2 squared, sorry, 2 to the 4 power times 3 times 5. What's 2 to the 4 power? That's 16. And what's root 16? 4. So that's 4 root 15. So really what you got is 15 times all that junk, right?
So it's like 60 root 50.
Right, it's 60 root 15, exactly. Yeah, 60 root 15. Yep. Questions on that one? Meredith, good. 60?
Okay, so we have this chapter all along for the 3 times 5 on the outside. So it kind of went along for the right.
3 times.
While I was working on the 240 part. So the 240 part became this eventually. Because when I broke down 240, I got 2 to the 4. 2 times 5. And 2 to the 4 power 16. 2 to multiply, right? So that's a 4. We squared it. But you still have 15 that was along for the right. Exactly.
So ask questions. I know I go fast. Please ask questions. We're okay? Okay. Can I clear the screen? No, I'll give you guys time.
5.
Mhm.
6 over 3.
For what number, sorry?
5. Because you go times.
You
go times.
you get root 24 over 3.
Which is 2 root 6.
Over 3. You leave it like that, yeah.
And then you can't simplify that.
No. Okay. All right. Let's keep moving here. Now, I'm not sure what you guys have been told in the past for radicals in the bottom, but usually we want to, for these two problems here, rationalize the denominator. The bottom.
Okay.
Now, honestly, when I teach pre-cal and calculus, I don't care if I have radical, like myself as a calculus, I don't care. But what happens that when you do multiple choice tests, like especially when you're doing SAT, ACT, or if you're doing an AP calculus exam, which you guys probably might do in a couple of years, the answers are going to have the denominators with no radicals. The radicals will be eliminated from the bottom. So you need to know how that happens, that process. So I'm going to show you right now. And sometimes you have to use this as a skill for future problems that you'll do in calculus or other classes. So yeah, so we got to talk about it. So first off, if you have radical fraction,
You can break that like this. It's totally okay. There's no harm, no foul, because what if I have like 25 over 4, right? And I square root it. The same thing as that, right? I could actually root 25 and 4 separate. Not a big deal. I can totally try.
the problem is that sometimes the root 3 just looks nasty on the bottom. So we do something like this. Have you guys seen this before?
Yeah.
You guys done this in the past? Okay. So you get this.
6 is 40.
And the reason why it's 3 on the bottom, because what's root 3 times root 3? It's root 9. Okay, all right. So you probably did geometry. All right, cool. So it's not new. Okay. Okay. And then root 24, by the way, is 4 times 6. So it becomes 2 root 3. So you could think of this as 2 root 3. Oh, sorry, 2 root 6. I'm sorry. What am I talking about? Wow, I can't believe I just did that. That was terrible. Sorry, guys.
Could you divide the?
I am so glad you asked that, Lizzie. That is a great question. Probably the best question I've heard all year. Okay, now I'll explain why it's a great question. Well, the answer is no. Don't do it. But it's a great question. It's a great question. So Lizzie asked this question. So when you have this, can I do this? And this is also one of my pet peeves that really makes me upset. I literally blurt out 4-letter words when I grade this and students do this, especially when I'm pre-calculus and calculus. When the calculus students do this, I get really upset because this should not be happening. All right, and I have to make sure my kids are not around when I grade because I get a little heated. You can't do this, and here's the reason why. So this is bad. This is bad. Don't do this. Please don't do it. Why is this bad? Root 6. Some of you guys don't know this. This is actually
our fault in middle school or Algebra 1. We don't really teach, sometimes we don't emphasize it.
The radical is actually an exponent, believe it or not. That is actually an exponent. In fact, it's actually, you're going to learn this probably in chapter 5 or chapter 6. It's actually raised to the 1/2 power. You'll learn about this down the road. You would first have to evaluate this exponent first before you multiply or divide, right? Because doesn't e come before the m and the d in PEMDAS, right? So you would have to evaluate this. So you can't bypass the exponent step. The square root is actually an exponent. So to answer your question, Lizzie, no, because the radical doesn't let you, because it's like an exponent. So you have to leave it like this and just be happy with that. Because, for example, what if I have like root 16 over 2? Can I say it's root 8? Absolutely not. Because what is root 16, guys? And what's 4 divided by 2? 2 is not root 8. Root 4 is 2, right? Those are not the same. So you have to make sure that whatever pathway you take, it's getting you to the right answer. Yeah, I'll do number 4 really quickly. Yeah, please don't make that mistake.
Number 6, not.
I'm gonna do 7 in just a sec, but since Lizzie asked about 4, you can write like this. And what's root 16, guys?
4.
Done. That's it. No need to go any further. Yeah. If you want to multiply top line by root 16, go ahead. It's just going to be more circuitous if you do. So yeah, if you can evaluate a perfect square ASAP, totally do that, because that's going to make life much easier for yourself. And I have the answers in Schoology for this homework, so you guys can check it out. Okay, one more example from this group, and then I want to briefly talk about 9 through 13, which should be fast. Okay, so for number 7, you guys can do 8 for homework. I'll talk to you if you don't worry.
Aren't we doing the entire thing?
No, I'm doing parts of it. Okay, so this right here is called the conjugate. The conjugate is when you simply switch the sign in the middle.
Instead of going from negative, go to positive. You do both top and bottom. This is a technique which actually rears its ugly head in calculus. Like if you have any siblings or friends who are seniors or juniors in calculus, they're doing stuff right now.
And they're doing as part of their calculus work. It's a technique that can be very helpful in simplifying problems. Because here's what's going to happen. If I multiply the 2 up top, I get 2 plus 2 root 3. Then I have to FOIL the bottom. If I FOIL the bottom, I get 1, negative root 3, positive root 3, and negative root 9. What happens in the middle terms, guys?
They don't cancel each other.
Do you see how they cancel? Let me slow down a little bit. I know you guys are still copying. Let me take a
1
look.
minus 3.
Wouldn't that just be 2 plus 2 root 3 over 1 minus 1 plus root 9?
1 minus root 9.
1 minus.
Yes, thank you, AJ. So you have 2. Yes, the root 3's cancel in the middle. Yes, they do. We're gonna go a little further. You guys see how I got that in red?
Okay, all back up. So we distribute the 2. So firstly, you have to know to do this, because this is the opposite sign of this. And what happens is when you FOIL these 2, the radicals cancel. See, when I FOIL 1 with 1, I get 1. 1 with positive 3, I get positive 3. Negative 3 with 1, I get negative 3. Negative 3 with positive 3 becomes negative root 9. These cancel out because they're opposite in sign. And what's root 9? We know it's 3. So what's 1 minus 3? Negative 2. Now, I'm not done yet.
They do, yes. Now, in this case, you can do that. And here's the reason why. You can do that. You can. You could. We are able to.
I would just make it negative.
Because I could factor the 2 from the top. Let me erase this one because it's getting a little distracting. Yeah, so if I kind of work my way up, the 2's cancel here. Okay, let me back up a little bit.
Oh, wait, no, right.
You good? Okay. Yeah, these cancel. Oh, all right. Well, you're a good singer. Wow, that's a good voice. All right. Or you get -1 minus √3. I know it's quite a bit of work. You don't have to do it for one of the problem number 8. Now, I will once I finish the notes. Now, here's the deal. Because you guys can go through the other 3 problems, like because you're going to do 2, 4, 6. You'll go through them pretty quickly. Now, if you want to check your work, you can do this. If you like to check your work, so let me lower this. Oh, come on. Come on. What's going on here? Hold on. Sorry about that. Okay. All right. Much better now. If I clear my screen, here's how you can check your work. If I type in 2, and now you guys are more comfortable with the calculator of that project. If you do this, you get that right. If you do -1 minus √3, you get the same thing. I will promise you,
I will put a problem like this in the calculus section so you can check your work. I will make that promise to you guys, okay? Because obviously it's not to show me the calculator doesn't give you any advantage in terms of getting the answer no matter what, but it does help you check your work. So you can totally check your work just to make sure you did it right. That way,
you know, you walk out of a test. You walk out with confidence that, okay, cool. Yeah, because this is why I got my answer. I did all this algebra. It has to be right because I can get the same thing as I get from the original expression. So, because lots of you do all this algebra, you don't know if you did it right or wrong, right? Because you're still learning this. But the calculator can be a great way to verify. And I'll remind you guys, this is why we're going to spend 2 full days of review, right? So I want to help you guys come up with good test strategies. Okay, last bit, 9 through 9, 11, 13. I'll do those really fast. Like any equation, what's your goal in any equation? What do you want to get by itself? X. Yeah, that's the goal of any equation, right? That you're solving. You want to isolate a variable. So how would I begin isolating for number 9? Divide by 6. So let me just circle 9 because I'm doing 9 right now. So divide that by 6. And if you can use a calculator, by the way, don't do this in your head. Totally use a calculator. It's totally okay. It's 25. And you guys should know the square root of 25. What's the square root of 25? Or you gotta say plus or minus. Why do I have to give 2 answers? -5 could work if you square it. Also, here's the other reason why too. What if you were to graph? What if you had this here? What if you had y equals 6x squared, y equals 150? I know y equals 6x squared is a parabola. We've done parabolas a few times now, right? Y equals 150, I know is a horizontal line. I know that. How many times do they touch? They touch twice, don't they? And where are they touching? At 5, -5. If you so desire, I would strongly recommend you have Desmos out when you're doing your homework. Or when you're studying, see if you got this. So if I go y equals 6x squared, Desmos is so much better than the calculator. Y equals 150. Okay, you see where they touch? -5 and 5. So Desmos is a great way of verifying your work. Great way. Do it. Okay, the other ones really quickly. Then we're done. I promise. You guys have been troopers. Okay, how do I get x by itself for 11?
Multiply by plus
Add the 6. You could multiply by 25 if you wanted to, but you have to do it to everything. Maybe add the 6 first. What does x equal? Or -10. You get 2 answers. Yep. Okay, and then I'll leave that up. Let's look at 13. Okay, we'll give it. I know you guys are still jotting that down. Okay. Fine for 13. What do you guys want to do as your first step? There's a few ways you could do it, but you could FOIL. Okay. Actually, I'm glad Ellie brought that up. I'm gonna discourage you from doing that. And here's the reason why. Here's the reason why. I know I'm being very brash here. Yeah, I'll divide by the 4 first. You could FOIL first, but it creates way more steps. So be more efficient by dividing, not diving. Yeah, you could FOIL first, but it creates way more steps. So you'd be more efficient by dividing by 4.
Do x squared over 2. What is it? Didn't ask.
So let's do it right now. Let me erase those stuff because I need some space here.
X minus 1 squared equals.
Yeah, because if you were to do that, Ellie, what's going to happen is that you'll have this expansion, then you have to shoot the 4, then bring the 8 over, then you have to factor again. And that's just more work, you know. And actually, to be honest with you, that will require a quad form, I think, which we haven't done yet.
X squared minus 2.
So I would actually divide the 4 first.
X squared minus 2.
Yeah, equals 2. Good. Yeah, if you divide both sides by 4, that's totally okay. And then if you square root both sides to get rid of the square on the left side, you get x minus 1 equals plus or minus root 2. X equals 1 plus or minus root 2. Which is kind of like quad form in a way.
Oh, I did it wrong. Is that the same as plus or minus root
2 plus 1?
Root 2 plus 1.
Totally, yeah. As a good practice, try to put the radical to the right, just so it's easy, because it's like how quad form is designed. So just to be consistent, as a good practice. But yeah, but you're not wrong. So okay, now we're done. I promise. All right, so you guys can still get a head start on the homework. So the homework is going to be 2 through 14 even, and then 16 through 19 all. 16 through 19 all is kind of similar to what we just did earlier today in the notes. Well, 16 and 17 is. 18, 19 is just more review of old stuff.
So 16 through 19 all.
16 through 19 all, and 2 through 14 even.
I did all. 2 through 14. Yeah.
No, I know. I did the other parts with you guys. I know. Well, no, I mean, you're gonna submit. I said what you have to do. Let me update. I'll update Schoology. Hold on.
We just have to be in the lab. We just
Okay, here we go. Yeah, submit the other stuff.
One through 14 all, but you already did 1 through 13 all. You did it together.
Yep. All right.
Plus 180.